Today we will be solving Summer 17, Paper 31, question number 4. So the question says, the parametric equation of a curve are these. The range is given, so we have to express dy over dx in terms of tan theta. So let's do that. So for that we need to find out the derivative. Now, I've written down the equations here, so we need to find the derivative of x first, then we'll find the derivative of y. So to find the derivative of x, we know that the rule for finding the derivative of any ln function, this is the rule. Let's just write the rule right here. So this is the ln of any function. And this is our rule for finding the derivative of a ln function. So according to this rule, the derivative of the function, which is cos theta in our case, the derivative of cos theta is given in the formula sheet right here. So here you can see under differentiation, cos theta's derivative is minus sine theta. So I'll write minus sine theta over the actual function, which is cos theta. This part is our fx in this case. Now, sine over cos is the same as tan theta, so it will become minus tan theta. So dx over d theta is minus tan theta. Now let's find out the derivative of y. So 3 theta is the same as 3x, and the derivative of 3x is 3. So the derivative of 3 theta would also be 3. So dy over d theta is 3 minus, and the derivative of tan theta is given in the formula sheet. Here tan theta is, the derivative of tan theta is secant square x. Now that we have our derivative of y and x, we will find dy over dx. So to find dy over dx, we do dy over d theta divided by dx over d theta. So the d theta and d theta gets cancelled out, so we have dy over dx. So to find the dy over dx, we will divide dy over d theta by dx over d theta. So it is 3 minus secant square x divided by minus tan theta. Now, we will need to simplify minus secant square x. So we will look at the formula sheet. Under trigonometry, we are given this property of secant square theta. So 1 plus tan square theta is equals to secant square theta. So we'll just replace this value. 1 plus tan square theta. So it will be 1 plus tan square theta, and minus tan theta would be as it is. Now I'm simply just going to simplify. It will be 3 minus 1 minus tan square theta over minus tan theta. So 3 minus 1 is 2 minus tan square theta minus tan theta. Now if I rearrange this, I can write it as minus tan square theta plus 2 over minus tan theta. So in this way the minus signs will get cancelled out, so we are left with tan square theta minus 2 and tan theta. So this is our derivative. Now the second part. So for the second part, here I'm using a blue color. So for second part, it says find the exact y coordinate of the point on the curve at which the gradient of the normal is equal to 1. So we need to find the y coordinate. So for that we are going to equate the dy over dx to minus 1, because they are talking about the gradient of the normal. So gradient of the normal is minus 1. So dy over dx was 10. We just found out the dy over dx, so we'll write it as it is. Tan square theta minus 2 over tan theta. It is minus 1. Now I'll rearrange. So tan theta will go here. It will be tan square theta minus 2 is equals to minus tan theta. Now we can bring minus tan theta to this side so that we form a quadratic equation. So it will be tan square theta plus tan theta minus 2 is equals to 0. Now we can let the tan theta be u. So it will be u square plus u minus 2 is equals to 0. Now you can use the calculator to solve this quadratic equation, and our answer will be u is equals to 1 and u is equals to minus 2. Now replace the u with tan theta. Tan theta is equals to 1 and tan theta is equals to minus 2. So now we will find the theta values, and theta is equals to tan inverse bracket minus 2. Here theta will be, make sure your calculator is in radians when you are calculating these values. So here our theta will be pi over 4 and here our theta will be minus something, but as it's a minus value we're not going to take this, so this is not going to be taken. So our theta value is pi over 4. And we had to find exact y coordinate. So to find the y coordinate, we are given the equation of y right here. This is our y equation. Y is equals to 3 theta minus tan theta. So I'll write it down here. Y is equals to 3 theta minus tan theta. So to find the y, we needed the theta value. Now that we have the theta value, I'm just going to substitute 3 pi over 4 minus tan pi over 4. So if you input tan pi over 4, it is 1. So tan pi over 4 is equals to 1. So I'll just substitute it like this. It will be 3 pi over 4. So this is our y value.